Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 7 Integrals Exercise 7.3. So first sum, the given, find the integrals of the functions. So here so many functions we have. For the each function, we are going to find out the integrals. Now what is the first function that we have here? Sine square 2x plus 5. So in terms of integration, I am going to write down. So integral sine square 2x plus 5. So whether it is in the standard form or not, we are going to check. So we have integral formulas. So in this formula list, if you notice, we have only for integral sine x dx, we have a formula. So if it is only sine x, yes, we can proceed the integration. But do you see any power sine raised to 2 or sine power n? Do you see any formulas here? No, we don't have any formulas in this list. See, if it is sine square x, if it is secant square x, cosecant square x, we have direct formula. But sine square x, we don't see any formulas in this. Right? So we don't have a formula for the sine square x. So that means it has to be understood that the given function is not in the standard form. If it is not in the standard form, we have to do something, either simplification or substituting any other formula. Anyway, we have to bring it into the standard form. Okay. So for bringing this particular function into the standard form, I'm going to take help of some trigonometric formulas. So but in trigonometry, we have so many formulas, right? So choosing the right formula is the main task here. So basically sine square term where and all we are getting in trigonometry identity, if you notice, that is sine square x plus cos square x equal to 1. In this you can see the sine square. But when we write the function in terms of sine square, you'll be getting 1 minus cos square x. Of course, in this formula, no cos square x also we don't have formula. So when we choose this particular function, when we choose this particular formula, of course, it's not going to help us. Next, one more formula. So in where we are getting sine square x term means in cos 2x also we have a sine square x formula. Sine square term is coming over there. So that cos 2x formula is what? Cos 2x equal to 1 minus sine square x by 2. Sorry, 2 sine square x. So like this one formula we have. Cos 2x is what? 1 minus 2 sine square x. So like this one formula we have. So when we reduce this particular formula in terms of sine square x, yes, we can able to get it in terms of cos 2x. So cos 2x using the cos x formula, we can able to do the integration. So first we'll see what is sine square x in this. First sending 1 to the other side, cos 2x minus 1 equal to minus 2 sine square x. Now minus sign also I'll carry to the other side. So minus cos 2x plus 1 equal to 2 sine square x. We need only the formula for the sine square x, not 2 times, because we don't have any product 2 like that. So this 2 also we are going to send to the other side. At the same time, I'm going to change the order. 1 minus cos 2x by 2 equal to sine square x. So what is the formula for sine square x? 1 minus cos 2x by 2. So when we use this one, here, of course, integral 1 and integral cos 2x. For both, we can able to proceed the integration. So this is the right one to substitute here. But only in place of x, we have 2x plus 5. So wherever we have x, we need to replace it as a 2x plus 5. So integral 1 minus cos 2x is what? 2x plus 5 by 2. And then dx. Yes. So now we can proceed the integration further. This denominator 2 is a constant term. We can take it outside. So 1 by 2, 1 minus cos. This 2 I am going to multiply with both the terms. So 2 2s are 4x and 2 5s are 10. So 4x plus 10 dx. Now integration is applicable for both of the terms. Okay, both the terms integration is applicable. So now I am going to take integration also inside. I am going to split and write. So now integral 1 by 2 integral 1 dx minus integral cos 4x plus 10. dx. Okay, integral 1 dx is what? X itself. So 1 by 2 x minus, and integral cos x, we have a formula, right? Integral cos x formula is what? Minus sin x. This is the standard formula. We know that integral cos x dx is minus sin x plus c. This is the formula. So in terms of, but here we have 4x plus 10. So in place of x, we are going to replace it as a 4x plus 10. After that, if x has any coefficient, then we need to carry it as a denominator. See, normally while doing the differentiation, sin 4x plus 10, how we will be differentiating? Sin x differentiation cos x. Okay, so cos x, and inside part also we will differentiate. That's what we call it as a chain rule. So here the same concept, outer that cos, after integrating the cos function, the inside 4x plus 10, as usual we have to differentiate. 4x plus 10 differentiation is what? 4 plus 0. Right, that 4 plus 0 is 4. So that we have to write it as a denominator. So if you remember, in that way also fine. Otherwise, if you see any x coefficient, that you need to carry it as a denominator. So that's all. Now integration is done. Now put plus c. This 1 by 2, we'll take it inside. So x by 2 minus sine 4x plus 10, 2 4s are 8 plus c. That's all, the first sum solution. Now we can move on to the second one. We'll look what is the given function. So given sine 3x into cos 4x. So what is given? Integral sine 3x into cos 4x dx. So now we are going to look at the whether it is in a standard form or not. So we have integral formulas. Integral sin x dx, separate formula we have. Integral cos x dx, also separate formula we have. Do you see the sin x and cos x, if it is in a product form, do we have any separate integral formulas? No. Secant x into tan x we have. Cosecant x into cot x we have. But sin x into cos x is not in the standard form. So if it is not in the standard form, we need to reduce into the standard form. So now we are going to take a help of trigonometric formulas. In trigonometric formulas, where sin x and cos together, together, if it is in a product form, which formulas we are getting? In sin 2x formula we have, basically sin 2x equal to 2 sin x into cos x. It is in the product form, sin function and cos function in the product form. But if you notice, here x, here x, so whatever angle sin carries, the same angle only cos has to carry. But here for sin we have a 3x, and for the cos we have 4x. So this formula is not going to help us. So next, one more formula we need to choose. And we have a formula like sin A into cos B. So angle taking different, right? Sin function is taking a different and cos one is taking a different. So for this we have formula 1 by 2 of sin A plus B plus sine of A minus B. This formula we have. So now using this formula, we are going to write down. We are going to rearrange this part. Okay, using this particular part, we are going to change it. So if we change now, integral 1 by 2 sine of, what's happening here? A plus B. So both the angles are getting added. So here 3x plus 4x. Next, plus sine A minus B. So A and B is getting subtracted. So 3x minus 4x. That's all. We got it into standard form. So further we'll simplify. After that we can apply the integrals. That's all. This sum will be done. So this 1 by 2 is a constant term. We'll carry it outside. So integral sine 3x plus 4x is what? 7x. Then plus sine 3x minus 4x minus x dx. And in trigonometry, sine minus theta. So for sine function, if we have an angle, if it is in negative, we can carry it outside. Minus sine theta. So this minus sign, we can carry it outside. Then this one will becomes 1 by 2 integral sine 7x minus sine x dx. Okay, next one. Integral is applicable for both of the terms. So I'm going to split and write now 1 by 2 integral sine 7x dx minus integral sine x dx. The second part, it's in a standard form only. So integral sine x is what? Minus cos x. So integral sine x dx formula is what? It's a minus cos x plus c. Okay, so this part no problem. But if you notice, here x has a coefficient. So in place of x, we are going to write it as a 7x. So minus cos 7x. But x has a coefficient, right? As I told you that while doing the first term, if x has a coefficient, that we need to carry it as a denominator. Next, minus sin x integration is what? Minus cos x. So integration is done. So we can put plus c. Now this minus minus I am going to combine. At the same time, this 1 by 2 I am going to take inside. So minus cos 7x by 14 minus into minus plus cos x by 2 plus c. So that's all this sum. Now we can move on to the next one. Next third one, we'll see what is the given function. Integral cos 2x into cos 4x into cos 6x. Cos 2x into cos 4x into cos 6x. So we have in formulas, no? We have only integral cos x dx. So integral cos x into cos y into cos z. So it's taking three different angles. So we don't have such a integral formulas in that list, right? So what we have to understand from this? So the given function is not in the standard form. So we have to do some simplification and we have to reduce into the standard form. So for that, we are going to take a help of, as usual, trigonometric formulas. So in trigonometry, if you have noticed, we have one formula, that is cos A into cos B. We don't have cos A into cos B into cos C together, but we can able to simplify it. First two we will consider, and then the next one also slowly we'll make it as a simplified one. So first we are going to choose this formula, cos A into cos B. See, the formula is 1 by 2 cos of A plus B plus cos of A minus B. So we have formula like this. So out of here totally cos 2x, cos 4x, cos 6x. So three things are in product form. So any two will consider. Last two will consider. Let's keep cos 2x as it is. So as per the formula, we'll write down now. So integral, yes, as I told, cos 2x we are going to keep as it is. So as of now, we are going to consider only these two parts. For our reference, I am just putting the open brackets. So what is that? 1 by 2 cos A plus B. So cos A plus B, that is angles, right? Angles, first we need to add 4x plus 6x. Next plus, now subtraction, cos 4x minus 6x dx. That's all. Now this 1 by 2, we'll take it outside. Integral cos 2x into cos 4x plus 6x is how much? 10x. Plus cos 4x minus 6x minus 2x dx. Okay, so now again what we are going to do is for cos minus theta. So cos minus theta formula is what? Even for the cos function, if angle is negative, it's a cos theta only. So in allied angles in trigonometry, we have studied formulas like this. So for cos minus theta, it's cos theta only. So this one we are allowed to change it as a positive 2x. Okay, cos of minus 2x is what? It's again only the cos 2x, positive 2x. So 1 by 2 integral cos 2x cos 10x plus cos 2x dx. Now this cos 2x I am going to take it inside. 1 by 2 integral cos 2x into cos 10x plus cos 2x into cos 2x. So this one we can write it in the form of cos square 2x. And the first one, no, like one formula we have used cos A into cos B. The same formula we can use and we can expand this particular term. So what is that formula? Cos A into cos B. Cos B formula is 1 by 2 of cos A plus B plus cos A minus B. So this is the formula, right? So once again I am going to use the same formula for the first term. 1 by 2 integral 1 by 2 cos A plus B, that is 2x plus 10x. Next plus cos A minus B, 2x minus 10x. Bracket close. And this one cos 2x into cos 2x is cos square 2x dx. Now 1 by 2 integral this 1 by 2 1 by 2 applicable only for the first term, right? So as a common we can't take it outside, so we'll keep it inside itself. So integral 1 by 2 cos 2x plus 10x is 12x plus cos 2x minus 10x is what? Minus 8x plus cos square x dx. Okay, now as I told, cos minus theta is what? It's again a cos theta itself. So for cos function, when we have a negative sign also, we can write it as a positive itself, right? Even if the angle is negative, yes, it's a cos theta, positive theta only. So 1 by 2 integral 1 by 2, 1 by 2 for both, right? So 1 by 2 cos 12x plus cos 8x. Now plus cos square x dx. Now integration is common for this one as well as this one. Now 1 by 2 integral I am going to carry for this one. So 1 by 2 cos 12x plus cos 8x. And same this 1 by 2 also applicable for this plus 1 by 2 integral cos square x dx. Okay, next one, this 1 by 2 now we can take it outside. So that is 1 by 4 integral cos 12x plus cos 8x dx plus 1 by 2 integral cos square x dx. Now this integral is common for both the terms. So we can split and write it. So for the first two terms, so the cos 12x, cos 8x, we can able to integrate it using cos x formula itself. Okay. But when it comes to this part, no, cos square x. So we don't have cos square x as a standard form. So for cos square x, again what we have to do is, we need to write it as a standard form. So using some trigonometric formula, this cos square x we have to reduce into the standard form. See, for cos 2x, I told totally we have 4 formulas. So for cos 2x, one formula is cos square x minus sin square x. So using that formula, when we try to reduce, we will be ending up with the cos 2x and sin square x term. Again, sin square x, it's not in the standard form. So the first formula is not going to help. And second formula we have, that is 2 cos square x minus 1. So now this formula I am going to reduce in terms of cos square x. So sending minus 1 to the other side, cos 2x plus 1 is 2 cos square x. Now sending 2 to the other side, cos 2x plus 1 by 2 equal to cos square x. So in place of cos square x, we can rewrite what? We can rewrite cos 2x plus 1 by 2 dx. Now we got all the terms in the standard form. So now this integration I will carry inside. So along with the 1 by 4. 1 by 4 integral cos 12x dx plus 1 by 4 integral cos 8x dx. Okay, now we will integrate this part. Cos x integration is what? Sin x. So integral cos x formula is sin x plus c. Okay, cos x integration sin x. So 1 by 4 cos 12x integration sin 12x, and x has a coefficient that we need to carry it as a denominator. And same here also, cos 8x integration sin 8x. X has a coefficient that we need to carry it as a denominator. Next plus, okay, this 2 we can carry it outside. So 1 by 4. Okay, cos 2x. Cos 2x integration is what? Sin 2x. X coefficient we need to carry it as a denominator. Next, integral 1. Integral 1 is x itself. So integration is done throughout the step. We can put plus c. Now 12 fours are 48. So sin 12x by 48 plus sin 8x. 4 8s are 32 plus 4 and 2 will multiply. So sin 2x by 8 plus x by 4 plus c. So that's all the solution of the third one. Okay, now we can move on to the next sum. Okay, next fourth one, we'll see what is the given function. Sin cube 2x plus 1. So integral sin cube 2x plus 1 dx. Okay, in the standard form, only we have a sin x formula, right? Only we have sin x formula. If sin rise to some power, we don't have that formula, right? So then we need to reduce this one into the standard form using some trigonometric formulas. So here what I'm going to do is, first thing, I'm going to write this one as a sin square x into sin. So sin cube x we can split as sin square x into sin x. So this way I'm going to split and write now. So this becomes like integral sin square 2x plus 1 into sin 2x plus 1. And we have a trigonometric identity. What is the trigonometric identity that we have? Sin square x plus cos square x equal to 1. So sin square x is what? 1 minus cos square x. So now the sin square 2x plus 1 alone, I am going to write it in terms of 1 minus cos square x. So integral 1 minus cos square. In place of x, what we have? 2x plus 1. So cos square 2x plus 1. And then into sin 2x plus 1 dx. If you notice here, this cos 2x plus 1. Cos 2x plus 1 differentiation is what? Constant term differentiation 0. So cos 2x plus 1 differentiation, of course, we'll be getting it like a sin 2x plus 1. So we can able to get right. So what I'm going to do is, I'm going to proceed this sum by using integration by substitution. So one function with the other function, with the help of differentiation, we can able to relate it. So here cos 2x plus 1, I'm going to write it as a t. Okay, so let t equal to cos 2x plus 1. Next dt is cos x. Cos x differentiation is what? Minus sin x, that is 2x plus 1. And 2x plus 1, further we need to differentiate and we have to write it in a product form. So we are getting the result, and x differentiation dx. So we are getting the result minus 2 sin 2x plus 1 dx. This is what we are getting. So here we have sin 2x plus 1 dx alone. We have this part alone we available here. But minus 2 we don't have, right? So this minus 2 we can send it to the other side. Sin 2x plus 1 dx. So now we will substitute this stuff over here. So integral 1 minus cos 2x plus 1 is what? T, right? So this becomes a t square. And sin 2x plus 1 into dx is dt by minus 2. See now This much complicated thing we reduced into the standard form. Now it's very easy to proceed the integration from here. This minus 1, minus 2, no, this is the constant term. We can carry outside. So minus 1 by 2. So what is left now? Integral 1 minus t square dt. Now integral is applicable for both the terms, integral 1 dt minus integral t square dt. Now integral 1 dt is what? Only t, minus 1 by 2. Integral 1 dt is t minus, using exponent formula we have to proceed the integration, x power n plus 1 by n plus 1. So whatever we have for the power, adding plus 1 and same power we need to repeat in the denominator and then plus c. So minus 1 by 2 t minus t cube by 3 plus c. Okay, so now for our convenient only we changed x function in terms of t. But what is the t that we considered? Cos of 2x plus 1. So wherever we have t, we need to substitute as a cos of 2x plus 1. So cos of 2x plus 1 minus cos of 2x plus 1 whole cube. So normally for the trigonometric function, the power we can write it here by 3 plus c. If we want this minus 1 by 2, we can carry inside. Then it will becomes minus cos 2x plus 1 by 2. Minus into minus plus. Cos cube 2x plus 1 by 3 plus c. And one thing, this 1 by 2 we need to multiply by both the terms. So when we take for the second one, this becomes 6. Yes. So that's all this sum. Okay, and next sum onwards, that is from fifth sum onwards, we can proceed in the next video. And thanks for watching, and please do subscribe. Thank you.